All right, let's start off on number 2 here. So we want to solve these by taking square roots. So on this case, the squared is already isolated, so I'm going to go ahead and take the square root. And so on the left side, the square root undoes the square, so we're just left with n. On the right side, the square root of 49 is 7. However, the rule is that if you create the square root, you have to put plus or minus in front of that number. So I'm going to put plus or minus 7. The reason why is that if I did negative 7 squared, it would also equal 49. So you are allowed to just leave your answer like that. Sometimes, though, you'll see it split up as n equals 7 and n equals negative 7. They really mean the same thing. So I'm going to put an or here. You can list your answer either way. The plus or minus just means plus or minus, so that's why it covers both of those answers. All right, next up, number 4. So for this one, our squared is not isolated yet, so we need to isolate it first by subtracting 7. So that gives me x squared equals 81. That's x squared, okay. And then we're going to take the square root on each side. So x would equal plus or minus 9. Once again, I just have to put that plus or minus in front because I created the square root. Once again, you can separate that out as 9 and negative 9. I'm just going to leave it as the plus or minus. All right, next up, number 6. So for this one, we have a 9 multiplying out front here. So I first want to get rid of that by dividing it over. So that'll give me x squared equals 4. And then I'm going to take the square root on each side. And so x equals plus or minus 2. Since I created the square root, I got to have a plus or minus. Next up, number 18. We have this parentheses that's squared, but the squared is isolated, so I'm going to go ahead and take my square root as my first step. So then it's going to turn into x minus 15 equals. And now since I created the square root, I'm going to have to put plus or minus 11 since the square root of 121 is 11. So now I'm going to have to add 15 over to isolate x. And so I'm going to say x equals 15 plus or minus 11. Now on this one, I actually really do need to split this up and do it twice. Once as 15 plus 11, and then once as 15 minus 11, and I'm going to get 2 different answers here. So on this answer, I get 26, and on this answer, I get 4. All right, next up, number 10. So I'm going to take the square root on each side again, and so this will be x plus 1 equals plus or minus 4. And then I'm going to subtract the 1 over, so x equals negative 1 plus or minus 4. But again, I need to split that up into 2, so negative 1 plus 4 and negative 1 minus 4. So that'll give me answers of 3 and negative 5. All right, next up, number 12, we need to solve this by factoring. So I'm going to go ahead and do my x here, and I got negative 4 on top and negative 3 on bottom. So that's going to give me negative 4 and 1. I don't need to do the grouping here because we just have x squared out front, so I can just do x minus 4 times x plus 1 equals 0. So now I need to split this up into 2, so I'm going to set each of these equal to 0 individually. And then I'm going to solve them, so I get my 2 answers. So x equals positive 4 and x equals negative 1. All right, next up, number 14. So on this one, I want to get one side to 0 first. So I'm going to move this stuff over here. I really like to have my squared be positive, so I move everything to the side that makes that happen. I need to put this in kind of standard form here. And now I'm going to have to do my x. So I'm going to do a times c up top and b on bottom. So this will be 10 and 7. And so that's going to be 5 and 2. Now, since I have this 5x squared, that means I have to do my grouping technique or the inside-out box here. And so I put those out there, and then this middle one I split up according to my x. So I get plus 5x plus 2x. And now I'm going to do my grouping. So I'm going to group these and group these. The first group I can take out 5x, which leaves me with x plus 1. The second group I can take out positive 2, which leaves me with x plus 1. So then my factored form will be 5x plus 2 times x plus 1. That's equal to 0. So now I'm going to split that up. So 5x plus 2 equals 0, and then x plus 1 equals 0. And so I'm going to solve these. So this one, let's see. I'm going to subtract 2 on each side, so 5x equals negative 2, and then divide by 5, and so x equals negative 2 over 5. On this one, I'm going to subtract 1 from each side, so I get x equals negative 1. All right, next up, number 16. I see that we are already equal to 0. However, I do see that there's a GCF here of 5, and so I'm going to take that outside. Let's see, what's 65 divided by 5? 13, okay, so minus 13x minus 10. And so now I'm going to factor the inside here. So I'm going to think of two numbers that multiply to negative 30, which is a times c. add the negative 13, so that sounds like negative 10 and negative 3. However, I do need to use the grouping here since I have this 3x squared out front, so then I'm going to split this up as negative 10x and negative 3x according to this, and then I'm going to move this minus 10 out there. So now I'll do my grouping. So it looks like I can take out an x, which leaves me with 3x minus 10. On this one, I'm going to take out a negative 1, which will turn this into 3x plus 10 as well. So then it turns into x minus 1 times 3x minus 10 is equal to 0. Technically, we should have this 5 out here that I GCF'd at the beginning. But when I actually split this up, I don't need to set the 5 equal to 0. And so then this one is 3x minus 10 equals 0. So I'm going to add the 10. 3x equals 10. And x equals 10 over 3. All right, next up here, it's asking us to put this in vertex form. So we really need to figure out what a is. So I'm going to plug in my vertex here. I'm going to leave a as a variable. We're going to plug in the vertex. I'm going to put x plus 1. So we switch the sign of that. But the y value we keep the same. And then I'm going to plug in this guy as an x and a y. So 0 equals a times 2 plus 1 squared minus 4. I do need to do some PEMDAS here, so this will be 3 squared. And then 3 squared is, of course, 9. So I'm going to say 9a minus 4. We're going to add the 4. 9a equals 4. Divide by 9. So a equals 4 over 9. So now all I have to do is really just rewrite this first step, but with my a plugged in. So I'm going to say 4 over 9 times x plus 1 squared minus 4. Did not ask us for the standard form, just the vertex form, so I'm done. All right, next up, this one, it's asking me, does it have a max or min value? So anytime a is greater than 0, if it's in positive, then that's going to be a min because it's opening up. And then, so that's part A. Part B is what is the max or min value? That's the y value of the vertex. So I'm going to find the x value of the vertex. I'm going to do negative b over 2a. So that's going to be negative 6 over 2 times 3, which is negative 6 over 6, which is negative 1. I got to plug that back in to find y. So 3 times negative 1 squared plus 6 times negative 1 plus 1. And so we get 3 times 1 plus 6 times negative 1 plus 1, because negative 1 squared is positive 1. And now we multiply, so we get 3 minus 6 plus 1. And so that's negative 3 plus 1 is negative 2. And then lastly, domain and range. So domain on these ones is always all real numbers. And then my range, I'm going to say y. It always has to do with the vertex. So in this case, this y value right here is negative 2, and all my y values are above that. So I'm going to say y is greater than or equal to negative 2.